Complementary angles are angles that add up to 90 degrees. So you'll often see complementary angles indicated using a right angle symbol. So you will know that that's 90 degrees. Sometimes, though, the angles may not be right next to each other. They may be non-adjacent, even though they are still complementary. So that's sort of just the key words you need to know for this. So when they say find the complement of a 35-degree angle, we know that means what's the angle that we would have to add to 35 to make it add up to 90. So to find that, we'll do 90 minus 35. We come up with an angle of 55 degrees. Over here, we are asked to find the measure of angle 2. Nothing in here says that this is a complementary angle, but notice the right angle symbol, so we know that these angles have to add up to 90. So just like last time, we'll do 90 minus 68 to figure out what is missing to get this to be a 90-degree angle, and come up with an angle of 22 degrees. Supplementary angles, on the other hand, are going to be angles that add up to 180 degrees. When supplementary angles are adjacent, meaning they're right next to each other, we call them a linear pair because they make a straight line when you look at them right next to each other. But again, they may not be adjacent. They may just be two angles floating around that still up to 180, but often we'll see them making a straight line. So again, as long as we know our keywords, we'll see, the question is find the supplement, or find an angle that's supplementary to a 77-degree angle. Because supplement means they have to add up to 180, we'll do 180 minus the angle that we have, and come up with a missing angle of 103 degrees. And kind of like last time, the second example, they ask us to find a missing angle, and nothing says it's supplementary, but notice these two angles together make this straight line right down here. So I know that straight lines form a linear pair. They're 180 degrees. So these angles are supplementary. We'll do 180 minus 56 to come up with a missing angle of 124 degrees. This next question asks us to identify linear pairs, and we're going to just use the numbers to find angles, like to label angles. We don't have any letters this time, so I'm going to look for different straight lines in this picture. So one straight line people see right away is this line right here. And what I want to be careful of is I want to find only pairs of angles. So even though there's sort of angles on both sides of this line, these two down here are the only two that are a pair, like together, that make a straight line. So I'm going to say angle 4 and angle 5 are a linear pair. They make a straight line. Some people try to look at the top of this diagram and say things like 1 and 2 are also a linear pair, but look, they don't make a straight line together. 1 and 2 just go that far. People try to do like 1 and 3, but that's sort of missing that middle part, so those two aren't a linear pair either. Some people correctly figure out that 1, 2, and 3 together make a straight line, but again, we're looking for a pair, and 1, 2, and 3 is one too many, so it's not going to work. It turns out there is another linear pair in this diagram. If I kind of erase my drawing right here, I want to look for other straight lines, and I can see there's another straight line right here, and the two angles that are on that line are right there, 1 and 4, so there's another example of a linear pair, another set of angles that would add up to 180. So besides linear pairs and supplementary angles and complementary angles, we also have something called vertical angles, which are angles that are across from each other. They'll make an X. So we'll have a complicated sort of diagram to look at next, but just real simply, if I start with something like that, vertical angles could be angles that are in those two locations, they're across from each other, or same with top and bottom. This angle up there is a vertical angle with the angle down there. Oops, and I made the same mistake I did in class. Even that, so it's true, vertical angles are across from each other, but this blank should be that vertical angles are congruent to each other. They are across from each other, but more specifically to us, they're going to be congruent to each other, equal to each other. So let's go ahead and just identify some vertical angles, and then we'll take a look at using this to find some. So in this diagram, there are 3 sets of vertical angles. If it helps you, trace over only 2 of the lines at a time, so kind of ignore the other numbers around the diagram. And if I look at just those 2 lines, I can see that angle 3 and angle 6 are vertical angles. They're across from each other. Using similar reasoning, I can realize that angle 2 and angle 5 are also vertical. And then finally, angle 1 and angle 4 are vertical. And all those angles, whatever they are also equal to each other. 1 and 3, or 3 and 6 are equal, 2 and 5 are equal, and 1 and 4 are also equal to each other. So last up for this video, let's go ahead and put all that stuff together. Vertical angles, supplementary angles, linear pairs, and complementary angles to find all the angles in this diagram. Some things are given to us, so let's take that given information and get it inserted into the diagram. That should make it easier to answer the rest of the questions. So they tell us the measure of angle 1 is 35 degrees, so I'll label that. And they also tell me that angles 3 and 5 are complementary. There's one of those keywords you need to know, means 90 degrees. So what I'll do is find 3 and 5 in my diagram, and I don't know what each one is, but I know together they make 90 degrees, so maybe I want to put a little right angle symbol in that spot. So I know that those two angles together add up to 90. So you're welcome to try whatever methods you want. There's not like a right way to start this. So here's what I would probably do. I'm noticing this straight line right there. So I know that on that straight line there's 180 degrees, meaning angles 1 and angle 4 have to be supplementary. They have to add up to 180. So I may start there and say that, well, 180 minus 35 should give me angle 4. The difference there is going to be 145 degrees. So I'll get that in my diagram so I have some more information. So that's 145. I'm seeing another linear pair. I'm seeing another straight line right here between angles 4 and 5. So those two are also supplementary. So they also make a straight line. They also make a 180-degree angle. So I'll do another 180 minus 145. And I'll come up with 35 degrees for angle 5. Now some of you realize you could have found that even quicker because look, if I look there and I look here, I've got vertical angles, so they have to be equal, so those are both going to be 35. Next up, if I just kind of keep going around in this direction, I see that since I know angle 5 right now, and I knew that 3 and 5 are complementary, I've got 90 degrees right in this spot. So I'm going to do 90 minus 35 and come up with 55 degrees for angle 3, because that has to add up to 90 degrees. And then lastly, I have angle 2 to find. There's a few ways you could do this. Some people realized that, let's get green I suppose, some people realized that since this is a right angle, the other side of it has to be a right angle because they make a straight line, so people figured out that angle 2 was 90 degrees using right angles. Some people also use this idea of going all the way around the figure, and they knew that all the way around this should be 360 degrees. And so what they did to find angle 90 was they did 360, they subtracted 35, subtracted 145, subtracted another 35, and subtracted 55 and found the difference to be 90 to get that full circle. So many, many ways you could do these problems. Just know your vocabulary. Complementary is 90, supplementary is 180, and vertical angles are congruent to each other.